Hello again, my darlings. Our second set of notes for today are dealing with reflections. This is our second type of rigid transformation. So reflections are when you take a shape and you flip it. So it flips to a new position. The original shape is called the pre-image and the new shape is called the image. So you can do this algebraically with some basic rules that I'll show you, or you can just do it visually, and especially if you don't have one of these lines to reflect across, then you have to do it visually because there isn't a rule for every single line. Okay, so for these basic lines is to reflect across the x-axis. Well, all that happens is the x stays the same and the y changes signs, because if you are above the x-axis, when you reflect, you're now going to be below it. Or vice versa, if you were below it, you're now going to be above it. If you reflect across the y-axis, the x is going to change signs, but the y is going to stay the same, because you're either going to move from the right to the left or from the left to the right, so the x value just changes signs. Okay, the line y equals x, that's this diagonal line that goes uphill with a y-intercept of 0 and a slope of 1. All that happens, it's really easy, is y equals x, so the x and y just become each other. Y equals x, so x becomes y and y becomes x. All that happens is you flip-flop. Y equals the opposite of x, that would be the same line except going downhill. It would have a y-intercept of 0 and a slope of -1. And notice y equals negative x, or the opposite of x. So the x and y are still going to flip-flop, but they're also going to change signs. See how it's a negative x, so the y becomes the x becomes the y, and they change signs. All right, so the first example, we're going to reflect in the line y equals x. So we look up here, and we see all that happens is the x and y flip-flop. So this becomes -4, -3. This becomes -1, 0. This becomes -3, 0. And there's our line. Or what you can do is visually see, when you reflect across a line, you go straight at the line and go to the opposite side. So if I'm half a box to the below it, when I reflect, I'm going to be half a box above it. So you go straight at the line and the same distance to the other side. So you can either use the algebraic rule, or you can just visually look and see how far am I from the line and go to the opposite side. All right, so this one we want to reflect across x equals 1. That's this vertical line right here. We have to hit the x-axis at 1. Okay, so this doesn't match any of our common rules. So this one we're just going to have to do it visually. So what we do is we look at the original point and we go, okay, this is 1 to the left, so when I reflect it, it's going to be 1 to the right, which is the point 2, 1. Then I'm going to go to u. This point is 1 to the left, so when I reflect it, I'm going to go 1 to the right, so it becomes 2, 2. Then I go to point V, which is right here. This point is 1 to the right of the line of reflection. So when I reflect it, it's going to go 1 to the left, which becomes the point 0, 3. And then I'm going to go to W, and W is 1, 2, 3 to the right. So when I reflect it, it's going to go 1, 2, 3 to the left. So it becomes the point -2, 0. And again, notice these are rigid transformations. These two triangles are congruent. They're the same size and shape. These two quadrilaterals are congruent. They are the same size and shape. All right, so example 2, we're given the reflection and we want to figure out the rule. Which line did we reflect across? So to figure this out, the line of reflection, if you look, is always right in the middle between the 2 points that are named the same. That's what a reflection is. You're the same distance from either side. So I just looked and picked a couple points like the G and the G prime, and I found where's right in the middle. And then the F and the F prime, and where's right in the middle. and this line, this horizontal line, goes right through the middle. So this would be a reflection in the line y equals -2. All right, so same thing here. I took these 2 points and I figured out what's right in the middle. And I took these 2 points and tried to figure out right in the middle. So this would be the line of reflection. And it's going through the origin. It's downhill, so it has a slope of -1. So that's reflecting in the line y equals the opposite of x. Okay, so that's our rule. Okay, when we look at reflections, something else that also deals with reflections is called line symmetry. Basically if you cut a line down your face, your two sides of your face are mirror images. Or a heart, if you draw a line straight down the middle of a heart, the two sides of the heart are mirror images of each other. So a shape has line symmetry. That's a line that cuts the shape into two congruent parts, but those parts are mirror images of each other. So they have to be both. They have to be congruent and they have to be mirror images. And so a lot of times what I tell people to do is take these shapes and actually cut them out of a piece of paper and see, how this works. So for this shape, I can draw a vertical line, and the left side and the right side would be congruent mirror images. I could draw a horizontal line, and the top half and the bottom half are mirror images. But I can also draw two diagonal lines. If I draw this diagonal, then this side and this side are congruent mirror images. Or if I draw the other diagonal, this side and this side are congruent mirror images. So this shape has 4 lines of symmetry. Okay. The rectangle is a little tricky. A lot of people want to say 4. The horizontal works and the vertical works, but the diagonals do not work. The diagonals do cut it into 2 congruent pieces, but the key is they're not mirror images of each other. So they are not lines of symmetry. So a rectangle actually only has 2 lines of symmetry. And that finishes up reflections.